So we're going to talk about now the imaging parallels between a tricuspid TEER or transcatheter arterial repair and transcatheter tricuspid valve replacement. Although the two devices are very different, the actual principles of imaging are pretty similar, I would say. So what I would do is that I would just lay it out by showing both echo and fluoro, because I think it's important to understand both. Okay, so let's start with the working view of the TEE. Okay, so this is tricuspid. Doesn't matter whether it's TTVR or TTVR. You're still talking about, again, back to your inflow view, right? This is your RVOT. This is your aortic valve. And then when you explain that, you're going to have the view of the septal, and depending on where you are, you maybe anterior, posterior. Okay? Pretty much, well, this is our call home view. In fact, this is the same as if you use ICE, okay, intracardiac echo. The 3D, this is also be your home view. Now, when you do your MPR, you're basically just extending this to now a 3D, right, which is aorta here, and then you have your septal, anterior, and posterior. Okay, so in the case of transgastric, we kept it the same way for consistency. Like this. Okay, so now let me draw this now in parallel on fluoroscopy. Okay, so this is now fluoro. This is TEE, right, slash ICE. Okay, so fluoro. So remember, fluoro is, what are we looking at? Aerial projection, right? Okay. So let's talk about the tricuspid valve here. So roughly it's going to be like that. Okay. So now I'm going to draw the devices. So on fluoro. So with the TriClip, for example, or even Pascal, or any other TEER device, you're going to be going this way, right? So we thought, let's not go into the RV yet, right? This is RA, RV. So this direction would be A, S, right? This direction would be P, S. Okay, so let me just do that here. And remember, RVOT is up here. Okay? So AP is going to be more like, the arms will be like this. We talked about this in another lecture. Okay? So now with TTVR, you have to think about the same principle, right? So your device coming up, and then you have advancing this, and then now you have this kind of situation. Okay, so now you have your nose cone and your stiff wire is in the apex. Okay, so you should be aware that there's orientation. Again, this is A and P. Remember, septal is behind you, right? On this view, with the left ventricle is behind this screen, this board. Same thing here. Anterior, posterior. Again, septal. So you don't know how septal you are with either orientation. That's why you need to look at echo, right, to see. Okay? So, for example, you have, this is very, very important. So here, for TTVR, you use called primary flex, right? Primary flex is basically flexing this way. Okay? What would be the equivalent for TriClip, for example? F naught, right? So it'll be F naught will be going this way. Now you'll be very careful when you do too much F, it's going to go to have a dive towards the free wall, the posterior part of the valve. Okay? So it's very important to stay in perpendicular. So you can see now primary flex on the Evoque system is actually the equivalent of the flex of this. Now, with secondary flex, you're just orienting a little bit more coaxial. That's a little bit different. And here you would be doing, for example, the SL knob on the TriClip on the guide to be able to optimize that. So that's the same equivalence. But that's how you know whether you're going to be doing dive here or not, and you have to be very careful about coaxiality. Now, there's a very common scenario where we call it a septal hugger, right? What does a septal hugger mean? I think it's very important to highlight, and you can have it for both devices, right? So you can have a septal hugger where the trajectory of the device is going this way, okay? So that's this orientation, okay? This orientation here is anterior and posterior. It's nothing to do with septal lateral. So it's very important that you appreciate that, okay? So when you have your device across like this, okay, let's just do an example here, okay? What you need to tell the imager is the following, okay? This is straight, correct? Everyone agree? Now, what if there's a situation where you're going like this? That is called anterior bias, right, or anterior dive. This is posterior dive. So whether it's TriClip, what do you do if it's doing this? With TriClip, you would flex more, right? If it's posterior dive, you would unflex. Now, with Evoque, you have to see also where you are, right? So if you are going to this dive, you can flex some more. But remember, you have a stiff wire. So if you flex, look at this here. If you flex, it goes this way. But then your stiff wire might be holding you back. You might have to pull back the stiff wire a little bit to allow it to drop down. Okay, you understand what the principle is? And if you flex it too much, you unflex, right? You can see the wire bending. You can also naturally adjust the wire. Okay, so same thing here. If you unflex, you'll stand up. Now, the other thing that we didn't say, right, that's just angulation. What about translation? We haven't even talked about translation. We'll talk about a septal hugger last because that's actually the trickiest part to talk about. So let me just talk about this. So now with TriClip or Pascal, for example, the TTVR device, you want to see where you are, right? So this is more anti-AS, right? Okay? If you want to go posterior PS, you have to retract the system, right? You have to go this way, or vice versa. Okay? Now, with TTVR, it's the same thing, actually. So, how do you know on fluoro, just before we move on? So, you would see that on fluoro, okay, that your device for the TTVR is here.
It will move back.
Right? Let's see, it's here. Right? So you need to retract the stabilizer and the whole system to go more central or posterior, whichever your target is. Okay? Now, let's look at TTVR. Okay? So same principle, right? So TTVR, the stabilizer actually clicks. So you actually counterclock the click to bring the state. You don't have to shift it manually. Okay? And so that will allow you to go this way. Okay.
And lift the wire up like
and that now, but remember, you want to go this way. Make sure it goes this way and not going like this. Okay, so you have to see how the wire is behaving as you come along. So if you want to go very slowly, because remember, there's a delayed transmission of the tension. Whether you go posterior, anterior to center, you want to, for TTVR, you want to center the device, right? That's the key. Whereas for TTVR, you want to grasp where you're supposed to grasp in the target. So center is not always the answer. So you have to be very, very much be cognizant of where you are on that. So for example, here, it's going to be more AS commissure. Here, it's going to be more PS commissure, right? So for TTVR, you need to make sure that whatever your target is appropriate, okay? And of course, with MPL and Transgastric, you'll see that, right? This is AS commissure, right? This is more PS, so same thing. So if this shifts this way, this shifts this way. Okay, same thing with TTVR, right? With the same thing, right? If your device is here, I'm too anterior, right? I need to kind of remove some clicks to move it central, right? Okay, and then so you do the same thing, and you should see it on MPR, right? If you're doing this, unclicking and it's not moving, what's going on? That means you're stuck in something, right? So don't keep going. You have to see what's going on. Is it because the nose cone and this is interacting with the subvalvular apparatus or moderator pen? So anytime you move, you shift your device, and it's not seeing it on fluoro or echo, you have to ask yourself a question. Why? Okay, and remember, fluoroscopy is higher resolution than echo. And remember, sometimes the imager may be following you. Okay? So it might look good on echo, but fluoro has not moved. So just beware of that mismatch and disconnection, because remember, this MPL, if it's reference to device, it changes, right? Depending on where the device is moving. So it's very important to understand the frame of reference of this, and also understanding the movements in principle are the same between TTVR and TTVR in terms of angulation, as I mentioned before, flex and unflex, right? Or translation, anterior septal versus posterior septal. It's really just the two dimensions. Okay? So now that is one set of movements. The next set of movement that is very important, okay, and is critical, especially TTVR, is this whole concept of septal hugger, right? So what does septal hugger mean? Let me go back to it. Is that the device is biasing towards the septum. So you have a what we call a lateral dive. Okay? If it's a reverse septal hugger, you're going to be going more a septal dive. So when you do when it's a lateral type of septal hugger, right, you can correct that for TriClip system by adding an L-knot, right? So you go out, and then you can then clock the guy to both septum. Remember, it's septal bias. You want to actually go towards the septum, so you have to clock the guy, right? So you basically go like this, and then you clock back to stand it up. So kind of like the aorta hugger. Remember talking about aorta hugger for mitral?
Plus.
Right? So you add plus knob, right? And then you counterclock to go back anterior. You say standing up. Now, TTVR is actually similar. Yes, there's a secondary flex to help you, but first thing we like to do actually is to clock the whole system. Not so much, because remember, there's a stiff capsule. But you can see that when your TTVR system is like this, you clock a little bit, actually would help a little bit already. Then you fine adjust, because you don't want a lot of flexion in the system. It's going to store a lot of tension because you have a stiff wire. So beforehand, so our preferred approach is to actually, for any septal hugger or lateral dive, as I call it, you can optimize that with TriClip. That's pretty straightforward. And then for the TTVR system, you do the same, and then you fine adjust with the secondary flex. Okay? Why is that important? People say, well, why do I need to do that? For two reasons, right? One, it makes your grasping for TTVR easier. Okay, so let me just show this here. Actually, let me just leave it here. Okay, let me just erase this part a little bit to show the concept. If it's TTVR, remember the septal leaflet is usually the shorter one, right? It's like the posterior leaflet of the mitral valve. So if you come up the grasp like this, and your septal is retracted, it's gonna hard to hook it, right? You want to be able to do it in a more coaxial manner, so you can cup the two leaflet. Especially tricuspid, it's flimsier, there's respiratory variation, we talked about that before. So you want to ideally be like this, right, when possible. Sometimes it's harder to do that. You might be maxing out on your SL now, okay? So that's important, right? You guys agree? Same thing for TTVR, right? So remember, typical TTVR systems deal with what? Very challenging anatomy. Use a retracted leaflet, very dilated annulus. That's why we can't do TTVR. So think about this, right? This is your Evoque now. Let's say you have your stiff wire here. Okay. You expose the anchors now, it's like this, right? Agree? So you need to do a flip. But the problem is that if you do too much of a flip, you can't swing to grab the leaflet. So you need to be able to get enough exposure of the anchors to be able to, grab the leaflet. But if you have a septal hugger or lateral dive, you're gonna struggle. So what you need to do is exactly like what you do with TTVR. You stand it up, right? You clock a little bit this way. If it's not responding very much, then you do your secondary flex to be able to optimize that. Okay? So that's very important for both TTVR and TTVR to stand up in this orientation. Has nothing to do with what I talked about earlier, angulation in terms of anterior posterior dive or translation. And okay? This is purely on this orientation so that you are coaxial at this plane and at this plane. This is a prerequisite for TTVR. And would be, I would say, almost similar to TTVR. TTVR, you have a little bit of a wiggle room because you can do independent grasping. Mm-hmm. You can't do that for TTVR. You have 9 anchors, and you need to get all the 9 anchors in with the leaf insertion. So you want to position yourself as center as possible with the TTVR. Okay? So now, we talk about the basic principles of maneuvers of both systems. That makes sense in terms of the turns and the knob. It's actually, in principle, very similar between the two, as long as you understand how the device works. So now, what we need to talk about next is about once you start to, for especially TTVR, okay? Once you have the anchors exposed, okay? So we need to do what we call the spin, right? Everyone talks about a spin. So let's just, for a moment here, focus right on TTVR because, for TTVR, it's pretty much just grasping afterwards. So here, now you have your anchor exposed, like this, right? This orientation, and let's just optimize the orientation here. So, right, you want to be coaxial. Okay, and now, this view is very important. Right? Going back to the MPR, right? Suppose I MPR the device. The device, let's say, is here. It looks good, right? You have the device reference, but you're totally offside. So if you're here and you retract, you should see on this transgastric, this is going towards the center. If not, you're caught in something. And you should be able to tell on your fluoroscopy as well, right? Because what you see that is like this, it's dragging. Because this is pulling back, right? It should look like this. That means something's caught. If it's not caught, it should be going this way, like this, perpendicular, okay? So now you're here now, then you have your anchors exposed, right? Okay, so let's say there are 9 anchors that are being exposed, and you do your spin. So you need to have a reference point, okay, in terms of this plane, and then this plane where you're starting off. You need to know where your commissures are, right, to be able to know. Now, we always, at least in our practice, use this box because it's the highest resolution to look at the top right corner. So if we start here, okay, we need to say we're starting at either 4 o'clock, whatever, pick whatever reference you want to baseline you start. And you need to look here to see. And then you need to systematically go, you can go counterclockwise, clockwise, doesn't matter. You just have to pick one way so that every time you do the same way so you don't get confused. Okay? Now, here's the trick, right? Sometimes, a lot of times, they have RV leads, CIED leads, or some other device. You shadow, you can't see, right? So, when you are spinning, pay attention not just this side, but this side, right? Why is that? Well, if you think about this is across that beam. Okay? I'm spinning, I'm here now. I can't see here. Well, maybe if I see here, I can see this side. That was one of the recent cases that we did. When we come here, it was so shallow you couldn't see it with TriIce. But when we go back to here, you actually could see the leaflet, the engaged capture here. Remember, this is the same beam that's beaming across.
So for every anchor, you actually have two places to look at it.
Correct.
Because,
so you always
use
look
of
for
all
both.
possible ways to
You're
look
focusing on this one point because but your eye you need to train in one location. You don't want to go back and forth. But as you go, you want to focus on this. But if you're having trouble on the opposite side, especially you have leads, you have a commissure, you're not sure, you might be able to optimize the image first. That would be ideal. Or you can go across. So we did, actually, one of our recent cases, we had that challenge, and we're able to confirm that by looking on the opposite side. So don't forget. Now remember also, sometimes when you're so focused on this part spinning, you actually drifting the image offside. So you just ask your imager to recalibrate, recenter, so you might be able to see both sides. Okay? And don't forget, remember when you do this, okay, what happened? Your 90 degrees, right? You have a crosshair, right? That's this side. So I'm also looking at this side at the same time. Maybe when you spin it, I can't see this side, but before I could because everything is all perpendicular. So you actually have 4 quadrants to look at. Obviously, you focus on one because you're doing the rotation. But if you have trouble imaging other parts of it by the time you do your spin, maybe because you're off center or there's some, you can actually use that to your advantage. So that's the trick to confirm leaflet capture for a leaflet capture TTVR device like Evoque. Okay, and for here on the imaging side, on this side, so let's just clear this up. Okay, so let's just put this now device in the middle. You have your anchor now exposed. This is your nose cone, and then your wires here. So here you can also check for other objects, right? If CIED lead, you should be able to see immobility. You should be able to look at LAO, so an LAO projection. Let me just draw it here. A little space here. This is LAO. Remember this LAO. You will see here the capsule, and then you have your. And then you'll be able to see where the lead is, or if there's a TEER device there before, you know roughly where you are in terms of orientation. You can kind of match it here to see, to confirm. So we often rotate back and forth to get your fluoroscopic view as well. Okay, so this is a very important point in terms of how you image on your MPR to confirm leaflet capture. Now, the other thing with the TTVR that's important is that if you need to, now your anchors are flipped and you need to get some more, remember it's not like a TTVR device, it's not as flexible. So now you need to kind of adjust. If you want to go here, right, this is A and P. If you need to go more A, right, there are 2 ways to do this, right? So either you unflex to bring it up, but then you might actually change the trajectory. Or you might actually withdraw the system, unclick, right? You click back and let it tilt up like that. That's a because remember that this is the pivot point.
Okay, because you're pivoting at the bottom.
Yeah.
Yeah.
Yeah, but you go, so you're pivoting here. Remember that's what they did in training. If you need to go this way posterior, you might actually just advance the system and stand it up like that. Okay, rather than flexing, because anytime you flex, you might have inadvertently changed the orientation of the other cyst size. And fluoroscopically, you should see it. Okay, if fluoroscopically you're not seeing the translation, something is going on. You're stuck with something wrong. So you have to confirm echo and fluoro. Okay, so this is the difference between the TTVR system and the TTVR system. But you can see based on this lecture here, the knobology and the device handling in terms of the views are fundamentally very similar. And you can actually, once you get comfortable with one device, you can actually translate your knowledge into the other.